In this video, I want to cover some of the basics as to why you may want to consider incorporating threading into your application. Now, if you've ever had a program where, for example, you clicked a button for it to do something and it ended up hanging and you couldn't really interact with the other program until the task was completed, that's kind of a case where you may want to incorporate threading. For example, I just copied and pasted this crap here, and this should take a little bit to run. So if we go ahead and launch this, we can see how long it's actually going to take. All right, so that took 5.052 seconds to actually complete. And during that time, that means there was 5 seconds where the user could not actually do anything. And I'll go ahead and write something up to show you really quick. So if we just, let's say we have a looping application, so I'll just do while true and some basics. So if get async key state, vkf1, I'm going to have this one be what executes the long compute time function. And then I want to have another one that simply prints out a string. So whenever we press F2, so that way we can kind of see if the program's locked up or not. So let's just do main thread unlocked. All right, so let's go ahead and run this. So I'll control F5. When I press F2, as you can see, I can spam it. Now I'll press F1, and now I'm pressing F2, and nothing comes up until the thread is finished. And then I can, keep pressing it again because the thread is now unlocked. So that's, that's obviously a problem. So what we can do is we can include space there. We can include threading, and we can go ahead and set up a thread. So std thread, I'm just going to call it thread, keep it simple. And where we call the function, instead of doing it the normal way, we're going to instead do it through the thread. So we're going to do thread equals std thread. And here's where we pass in the function. So long compute time. So this will instead call the function, but it will call it on, it'll make another thread for it to run in. So I'm going to go ahead and press Control F5 to launch again. I can press F2 just fine, but when I press F1, and now I can spam F2, I can still spam it while I wait for the function to complete. So as you can see here, the main thread was not unlocked, and I can still go through and do whatever I need while it was running. So it allowed me to do this, whatever function you may have, this long computation, without actually having to wait for it to complete. So that's kind of one of those use cases where instead of having the entire program lock up, this is obviously going to be dependent on your case, but instead of having the entire program lock up when you do something such as clicking a button and you have to wait for whatever task to complete, you can instead do something along the lines of maybe consider disabling that button after it's clicked, and then spawn your task on a new thread, and then once the task is complete, re-enable that button, so that way the user can, use it again. But during that computation, your program's not going to be locked up because whatever task you had that was running is going to be on its own thread. It's not going to be locking up the main thread like it was whenever we did the normal function call, because this calls it on the main thread. This will spawn it on its own thread to run. So that way we don't have to worry about any of that annoying stuff of locking up the program. So anyways, this was just kind of a short little thing as I was a little bit bored, but hopefully you found it useful. And as always, if you like what I'm doing and you want to help support me, you can find a link to my Patreon down in the description below, where I have a C++ series for Unreal Engine, where we cover Team Deathmatch from the ground up and then add much more features in there. If you have any questions or anything like that, feel free to join my Discord that's also linked down below, and I'll try to help you out. So I'll see you in the next video.